All right. Hey guys, so in your cool down yesterday, I asked you to find the IQR for the data listed. So for you to be able to find that, you had to first put the data in order numerically. So it is not in numerical order. So I should have 5, 6, then 13, 18, and 18. And so if I'm looking at this list of data, I find the middle. I go 1, 1, 2, 2, and I have 13 in the middle. Since that value is the very middle, that's my median, and I don't include it in the first half or the second half. So then to find my quarter 1, I have to look between 5 and 6, so it would be 5.5. And then my quarter 3 would be between 18 and 18, which is 18. Okay. And so in order to find the IQR, so my IQR or interquartile range, I take my Q3 and subtract my Q1. So I would have 18 minus, let me erase that, minus 5.5. And 18 minus 5.5 is going to give me 12.5. So the IQR is 12.5. And so that just tells me that the middle 50% of the data ranges from 12 and a half values on the number line. So that's how spread out the data is. Okay. All right, so today we're going to talk about our mean absolute deviation. Let's see if I can get my pointer back here. So mean absolute deviation is another measure of variability and a measure of center determined by the mean of the distances of the data points from the mean of the distribution. So this is kind of a long process and it takes a little bit of time, but it is basically a value to tell us how it's related to how widely spread out the data is. So it tells us another center of measurement to tell how spread out the data is. So for us to do this, we have to first know the data values. So your data values are right here in this first column. Okay, so it's really beneficial to have this data written in a table format so we can keep our numbers straight. So our data values are listed in the first column, and then I've already given you the mean. And so if you've forgotten from yesterday, how we find the mean is to add up all of those numbers. So we would have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 12. And so we take all of those numbers, add them up, and divide by how many values we have, which is 1, 2, 3, 4, 5, 6, 7, 8. So we divide that number by 8 and we get 5. So that's how we calculate the mean, in case you have forgotten from yesterday. So I'm going to erase that for right now. So we found the mean and simply written it in this second column. So right here, we wrote 5 all the way across, or all the way down. And so how they found the deviation from the mean is to take the mean and subtract it from the data value. So 1 minus 5 equals negative 4. 2 minus 5 equals negative 3. 3 minus 5 equals negative 2. 4 minus 5 equals negative 1. 5 minus 5 is 0. 6 minus 5 is 1. 7 minus 5 is 2. And 12 minus 5 is 7. So that gives us the deviation. It tells us how far away from the mean or the average that data value is. The absolute deviation from the mean is simply the absolute value of that number. So if we put our absolute value sign around it, it just makes that the total distance from the mean. And so you're not going to have those negative numbers. Okay, so -4 becomes 4, -3 becomes +3, -2 becomes +2, and -1 becomes +1. The other values are going to stay the same. Okay, so now to find the absolute deviation, so the mean absolute deviation, we're going to take these values. So we found how far away each data point is from the mean. Now we're going to take those absolute deviations and find the mean of those. So here I typed that on there so you could see it clearly. So we would take 4 plus 3 plus 2. So we're taking these values right here. And I have them typed right here. 4 plus 3 plus 2 plus 1 plus 0 plus 1 plus 2 plus 7. There are 8 values. So we're going to add those up and divide by 8. And we get a mean absolute deviation of 2.5. So that tells us that most of the data points are about 2.5 units or values from the mean in our data set. Okay, so it's just another way to look at how spread out the data is. On the next slide, we're going to do this with another set of data. So let's go over there. Let me erase that. Whoops. So here we're going to calculate the mean absolute deviation using the same data from the previous activity that we had earlier and find the average distance from each data value to the mean. So I provided you with a table. In your table, it will tell you if you're correct. So you will be able to tell if you have the right answers. So make sure you get that check mark. So let's look at the first one. So I'll get you started and then I want you to show me that you can do this. So the first thing you have to do is find the mean. So the mean of your original number. So we're going to take our data values and you have to add all of those up. So we would have 72. You can actually, if I'm over here, we'll have 72 plus 75 plus 81. So we can add all of those up and get our total value of 614. Let me fix that. That's a little rough. Okay. Since we're not finding the middle of the value, we don't have to put those numbers in order numerically right now. But if we were finding the median, we would have to reorganize those numbers. Since we're adding them up, we can leave them the way they are. Since we have our total of 614, your next step is to divide that by the number of values you have. So we have 1, 2, 3, 4, 5, 6, 7, 8. So you're going to take 614 and divide that by 8. Okay, so I've got you set up. So you're going to put your mean here, and I'm going to let you calculate that on your own. And then after that, you're going to take your data value and subtract it from the mean, whatever you have here, and it will give you the deviation. All right. So after you get your deviation, you're going to take the absolute value of that. So if it was a negative value, it would become positive because we're talking about total distance from the mean. All right, so make sure when you type in your numbers, you get a check mark. If you don't, try to rework it, okay?